figure out the area of a triangle in 3D space. Now, let's say we have a vector AB and we have C, right? And so we do have a triangle in which two are vectors and the third is the resultant vector. Let's say A is x1, y1, z1, B is x2, y2, z2, x3, y3 and z3. Now we know that the area of a triangle is half that of parallelogram, and we know that the area of a parallelogram is the cross product of the two vectors. So what that means is, if we take a parallel line parallel to BC and parallel to AB, we will end up with a parallelogram. So the cross product would be the area of this parallelogram, and which means half of that would be the area of the triangle. Now remember, cross product, it will also give you a direction, but we are not interested in the direction as such. Okay, so we are interested in the magnitude of that area. Okay, so area of the triangle is equal to half of the cross product AB cross AC. Now AB would be equal to OB minus OA, where O is the origin, which means OB and OA are the position vectors of B and A. So this would be x2 minus x1 I plus y2 minus y1 j plus z2 minus z1 k. AC would be, again using position vectors, OC minus OA. So this would be x3 minus x1 I plus y3 minus y1 j plus z3 minus z1 k. Now what would be AB cross AC? It would be I j k. So this is going to be the determinant of the y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1. Okay, so now we know matrices. So I times y2 minus y1, z3 minus z1 minus z2 minus z1 times y3 minus y1. Okay, then minus x2 minus x1, this will be j, x2 minus x1 times z3 minus z1 minus z2 minus z1 times x3 minus x1 plus k hat x2 minus x1 y3 minus y1 minus y2 minus y1 x3 minus x1. Now which means this can be written in short using the circular notation, right? So summation of y2 minus y1 z3 minus z1 minus y3 minus y1 z3 minus z1 I. So area of the triangle is equal to half of the cross product of AB and AC. So magnitude would be half of, remember, x square plus y square plus z square square root. That is what would be the magnitude. So summation of y2 minus y1, z3 minus z1 minus y3 minus y1, y2 minus, no, not y2, z2, the whole square and square root of. Now remember, it is in circular notation, right? So it is actually three set of terms. So this is what you should be looking at. So what this means is half of this expression squared plus square of this expression plus square of this expression and the square root of the entire thing. So this would be the area of the triangle. Now if we say that one of the points, one of the vertices or one of the vertex is the origin, right? If one of the vertex is the origin, then what happens is AOA cross OB cross, right? So let's take the determinant of this. I, J, K, x1, y1, z1, x2 minus x1, y2 minus y1, and z2 minus z1. One of the points disappears mainly because it is 0, 0, 0. So now find the determinant. So what do we have? We have I times y1 z2 minus z1 minus z1 times y2 minus y1 minus j hat, j times x1 z2 minus z1 minus z1 times x2 minus x1 plus k hat x1 y2 minus y1 minus y1 x2 minus x1. Let's open up y1 z2 minus y1 z1 minus y2 z1 plus y1 z1 I minus x1 z2 minus x1 z1 minus x2 z1 plus x1 z1 j plus x1 y2 minus x1 y1 minus x2 y plus x1 y. This is what it's supposed to be, y1 x1 y1 k hat. Now here this and this gets cancelled. x1 z1 x1 z1 x1 y1 x1 y1. So the overall expression becomes y1 z2 minus y2 z1 minus x1 z2 minus x2 z1 j and x1 y2 minus x2 y1. Okay, the area would be magnitude of this, right? Magnitude of OA times OA cross OB. So magnitude of this would be the square root of the squares, sum of the squares of this. So half of y1 z2 minus y2 z1 square plus x1 z2 minus x2 z1 square plus x1 y2 minus x2 y1 square. Yes. Okay, I think that's enough for today. Bye for now.